Okay, so last week we looked at sub-viewports in Godot to prevent clipping on your view model when making an FPS. And, well, let's be honest, the lighting sucks. Shadows from the world don't come through to your view model, and that's literally unplayable. So, how do we fix that? Well, some people will say to turn off depth testing, but they're wrong. This does not work. Well, it might for more simple models, but it's not a guarantee, and I'm going to explain why. I believe the best way to do this is with a shader, and thanks to some community members, it's now easier than ever. Project is in the description, let's get started. Okay, so let's talk a little bit about no depth testing. It's almost guaranteed that when you talk about viewport clipping, someone's going to chime in and say, use the depth test checkbox on the material, but that doesn't work. I've got this weapon from Kenny and I've got a lot of different materials on it and I've set them all up as no depth test, and you'll see the problem that you'll run into when you have multiple materials set up as no depth test. Obviously it renders over everything else, but you can see the barrel, you can see all the internals, it's drawn back to front, and the reason for that is because this particular model has multiple objects in it. So it's got multiple meshes, and what will happen is when you choose no depth test, that's probably fine for a single material, but when you have multiple materials, multiple objects in your mesh, you're going to run into this issue where the materials within that item or the meshes within that item will not test against each other, and they'll just get drawn sort of a little bit out of order most of the time. And so like this is why it works for simple models, but it doesn't work for more complex models, and especially for like a rig like arms and guns, because generally they're going to be different materials. So they're always going to get tested at different rates, and the weapon will get drawn behind the hands, which is definitely not something you want. So it's good for smaller scope projects, but you're going to need to sort of upgrade your view model material at some point, probably to a shader, I would say is the best way to go about it. You can also shrink your mesh. This is something that people were mentioning in the comments. You can shrink your mesh down to something smaller inside the collision shape so that it doesn't clip, which will also work, but I've never really been a fan of it. And also, like, you lose the ability to manipulate your FOV, which with a shader we can maintain. So I'm going to show you how to do that. We're going to jump into the project now. Okay, so I found, or someone linked this to me back when I was first trying to figure out this bug with the lighting in Godot 4, because I'd never tried a shader before, and they were basically saying that was the only option. So someone linked me to this page, to this YouTube channel, to Tuna Fish 117. So I guess 117 is a Halo reference. And he's got a simple method for viewport rendering. Now this is all in Godot 3. I'm actually not sure exactly which version. So he's got a GitHub, and this is MIT licensed. This is really important. We can absolutely use this code and we don't have to worry. So massive shout out to TunaFish117 for creating this repository so that we could use it. So I've got a Godot 4 compatible version already. I'm not going to pretend like I know how to write shader code, because I don't. So I'm going to give that to you. It'll just be under player controller viewport shader, and then under view model shader, you will find the view model shader here. Yeah, and like I said, I'm not going to pretend to understand this. This is something that someone provided to me. It's MIT licensed so that you can use this. It should have all the material stuff that you need. And we're going to write a script as well so that we can change the FOV as we work. So once you've got this shader, we want to come up to each of these objects. And what I find works best for like minimal changeover is just to come to each material that you have on your weapon and just click on this little drop down box and convert to a shader material, and do that for all of them. And this will save us the trouble of having to reset up everything. And then you can just drag the shader from the view model shader in. That's all you have to do. And you can see like the little circle gets a little bit lower. Okay. And we can see that now in space there. it will also in the viewport be drawn over the top of everything. So I think if you come back into this world and we just go like full screen in 3D, we can see that gun no matter where we are in the scene. So it's definitely working. Let's run the game just without doing anything else. And we can see it there. It's not being drawn through that. And when we walk into the shadows, it's all there. So everything is working as we would expect, which is amazing. So massive shout out to Tuna Fish for that one. That solves our shader problem. But there's a couple of things that we need to do to make this a little bit more workable. Because right now, every view model shader has parameters that we can change. So we can change the FOV. Obviously, you've got all your textures and your metallic and roughness and all that kind of stuff. So like it's just like a regular shader. It might be missing a few things here and there, but you know, for this simple project and most of the projects that I've worked on so far, this is enough. So we need to create a tool script for this so that we can change these FOVs on the entire weapon rather than on each individual shader on each individual weapon, because this one has like a different material for every single surface. That would be really tedious to change. You might just have one material per weapon or something like that, or whatever object you're drawing this on, and that's great. It's still probably a lot depending on how many weapons you have in your game. So I think it's good to have this tool script, plus then you can expose it to the settings in your game and the players can change their FOV if they want to, which is great. So I'm just going to go through and convert the rest of these weapons. Okay, so I've made all the changes. I'm just going to make sure that these are all working, and it looks like this one's all good. I believe the other weapon is here, and this is working too. So that's great. So now we've got all of that. Now let's set up the tool script so that we can make changes to, the FOV and all that easily. So it doesn't really matter where you put this script. I'm going to put mine on the weapon models node here. Just make it so that it's somewhere that makes sense for your project. So I'm going to create a new script, and I'm going to call this something like view model shader weapon models. Yeah, that's fine. We're going to delete everything. We don't need it. Actually, we might need the ready function, but we'll get back to it. The first thing we want to do is type @ and then we want tool, because this is a tool script. It's going to run in the editor. I'm just going to paste in the credit as well, so that you guys can see that if you need to find it. This is going to extend a node 3D. And this might be different for your project and all of those kinds of things. I'm going to make what works for mine. You might need to tweak this a little bit to work with the infrastructure of your project, but you know, we'll go with it. So I'm going to create another export variable, and it's going to be a mesh with shader. I'm actually going to make it plural meshes. We won't worry too much about the grammar meshes. Meshes with shader. And this is going to be an array, and it's going to be an array of mesh instance 3D. And then we're also going to export a variable called view model FOV. We'll make it a float, and we'll set this equal to 50. Now, I'm also going to set up a set get for this. So I'll just type :set, and then we'll set that equal to set view model FOV. And that will be the function that we need to do. Now, it's going to get cranky and says that the set is not found. So we'll come down here and create that function. It's going to take a value, obviously, and it will be a float like before. And we'll just set that to pass. And we'll also need to create another function, and we'll call it set mesh FOV. And that will also take the value as well. It will also be a float. So now what we're going to do is loop through those meshes for n in mesh with shader. We also need to check if it's null. So if n is not equal to null, so there is no shader or whatever, just protect us. We're going to go for I in range. n.mesh.get surface count. Now that will give us access to all the different materials within that mesh. Like I was showing you before, we've got like several different shaders within the same mesh. So we get the surface count, and so that'll be how many materials we need to loop through. And then next we need to get access to the material. So we'll go var mat is a material equals n dot get active material, and it'll need an integer for the surface. That's why we're looping through this surface count here. We'll pass in I, and then we'll check if mat is shader material, then mat dot set shader parameter view model FOV val, which comes from that. So what does this do? Now, probably I should also point out that within that shader, there is a value here, a uniform float view model FOV. So that's what we're setting within that. And it's set to 50 by default. And we're going to start manipulating that. So just to go over this, because this is a bit of like if you've never seen something like this before, it can mess with your head. I remember when I was making this, it was like pretty tedious. So it'll give us so basically we're going to get access to the mesh first, which is this mesh instance 3D. And so we're going to have an array of meshes. So this will be every single one of your weapons. And we're going to loop through each one of them. And then for every single one that has, a surface count with an active material that is a shader material. So we're going to basically go down in levels here. So we're going to say, okay, so if n is not null, so if as long as there's an actual mesh in there, then, because if there was nothing, then it would return null. We're going to get the number of surfaces in that mesh, which is like the number of materials. So that's like all these, surface 1, 2, 3, 4. And we're going to get the active material of that. I don't know why, but in my testing, specifying this as a material helps. And then within that, if it's a shader material, we're going to set that parameter. So like maybe there's a material here that's not one of these shaders. So we don't want to do it on those. So just keep it in mind, if there is a shader material without this value, I don't think it'll crash. It'll just throw an error. But yeah. So we've got that. We can save that now. Okay, so once we've written that function, we can come back up to the set view model FOV, and we're going to go view model FOV equals val. For some reason, I found that it works better if you do this. I don't think it's necessary. And then set mesh FOV to be view model FOV. Okay. And then we can come back to 3D. You might need to close the scene and reopen it for it to load up properly. So when we click on the node where we set this script up, we're going to have a mesh with shader and the view model FOV. So we can come to the mesh with shader and we can add some elements here. I've got 3. I'm going to drag my meshes into this. It should accept them. If it hasn't, then you might have set it up incorrectly. So I'm going to drag all 3 of these in. And then we can come to the view model FOV and we can start to change it. You can see I put a printout down there just to make sure it was working while I was trying to figure out why it wasn't. It's because I had to close the scene and open it back up again, which is really annoying. So I'll delete that. So we don't want that printing out all the time. So now we have a script that we can loop through all our meshes and change their view model. So we can turn this down to something like 45. We can run this. And it's 45. Now, this one doesn't have a slider, we can add a slider back in to this canvas layer like we did for the other one, and we should be able to manipulate the FOV the exact same way. There's a couple of, there's a couple of caveats that we have to address when we do it, but we can. So let's add a horizontal container like the last one, horizontal slider. So we'll come to the debug and I'll just click add and I'll go H slider again. Same exact deal. I'm going to make the max value 100's fine. Min value probably like 30, I think, in the end. And the starting value will make it 50 or 45 actually. In an ideal world, you would set this at runtime to be the default FOV that you decided on for your mesh. But we'll just make it static because it's easier. Okay, nice and easy. So when the value is changed now, we don't want to connect this up to the player, but rather we want to connect it to tool script. So we'll come down to the tool script and we will connect it to that on H slider value changed. And we'll set the view model FOV to be equal to the value. And that should just work. Okay, so we'll run the game and you can see that the slider is functioning for that. One thing that I feel like I should point out, like say if you wanted to have a signal to feedback that figure, so you create a signal, so you just set slider FOV or something like that. I don't know. And you wanted on ready to make that lowercase signal, and you wanted on ready to update that slider. So you create your ready function, and then you go set slider FOV.emit, and then you pass the value as well, the view model FOV. Now you're going to run into problems because every time you open this script, this is going to emit and it's crashed. I don't know if that was related, but I know that this becomes a problem. So you have to keep that in mind. It's gone. So we'll go back to that again. Signal dot set FOV at start or something like that. And in the ready function, we're going to add a little bit of extra here. So we will add if not engine dot is editor hint. Well, excuse me. And we'll write then set FOV at start, emit, and the actual value, the view model, FOV. Okay. And then we can come to this, connect this signal, come to your tool script, connect it to your canvas layer. It's going to receive a value. And that value will be, we can use it to set the slider. I'm just going to do a lazy one here. H slider dot set value no signal, and we'll pass in the value. Probably won't be able to see much, so we'll make this an extreme value, like we'll make this 100. And you can see the sliders all the way up and our gun looks ridiculous. But not like super important for this tutorial, but I thought it was important just to point out with tool scripts, if you do want to have it interacting with the game, definitely use this little extra bit of if not engine is editor hint, because otherwise you're going to be emitting that signal every time you start the game and it's going to crash the game like you saw. Okay, so now that we've set up the viewport shader, we can see that the lighting is once again working really well, the shadows are responding, and we're drawing the weapons above everything else, which is exactly what we want. So that's how you set up a viewport shader. In my opinion, this is the best way to do viewport clipping in Godot right now. Until they fix the sub viewports, I don't think it's worth using. Like I said, that still works in 3.5. So if you're using 3.5, that's perfectly fine. But in Godot 4, I think you're going to need to be using this viewport shader probably for a while. Godot has had issues with sub viewports for as long as I've been using it. So I don't think that's going to change anytime soon. And it's best just to use the shader. It works just as well. So the shader that I put on isn't exactly a principled shader or anything like that. So it might have some limitations there as well. So there's stuff to keep in mind, but it does work well enough, in my opinion, for most projects. Okay, guys, that is everything that I have got on viewport clipping. We've done sub viewports, we've done view model shaders, we've looked at no depth testing, and we also touched on shrinking the mesh. But I honestly believe that shaders are the way forward in Godot 4 right now. So if you found this video series helpful at all, I really do appreciate a like and subscribe. And if you want to support the channel further, you can always jump on the Patreon. Patreon members get these videos way earlier. You would have seen this 2 weeks ago. And as an added bonus, you get your name on the video right now. Be sure to check out the links down below. I've got the FPS weapon template down there for you if you need it. I've also got access to full tutorials on how to create that. But right now, that's all I've got for you. I'm Isaac from Shaft Games, and I'll see you next time.